Imagine standing on a sun-drenched beach. The water is warm, crystal clear, and sparkling. Families are laughing, kids are splashing, tourists are sipping drinks at beachside cafes. Everything looks perfectly safe, perfectly normal. But what if I told you that just a few hundred meters beneath that gorgeous turquoise surface, there exists one of the most toxic alien environments found anywhere on Earth? What if the sea you're swimming in is, by volume, 87% filled with a gas so deadly it can kill a human being in seconds? And what if that same sea is slowly, quietly waking up? And nobody on those beaches has any idea. This is the Black Sea, and almost everything you think you know about it is wrong. The story of this sea is not a travel documentary. It's part geological thriller, part ancient mystery, part apocalyptic warning. It involves a catastrophe so massive that it may have literally inspired the story of Noah's Ark. It involves shipwrecks so perfectly preserved they look like they sank yesterday. It involves underwater cities, burning ocean, fire erupting from the water itself, and a slow-moving chemical disaster that scientists are watching with growing alarm right now. So buckle up, because we're going all the way down. Let's start with the name, because the name itself is the first clue that something strange is going on here. Look at the Black Sea on a map or in a photograph, and it doesn't look black. On a clear summer day, it's blue. Near the shores, it turns green or turquoise. During golden hour, it's almost violet. So why does every culture, every civilization, every map across thousands of years keep calling it the Black Sea? The ancient Greeks were among the first outsiders to sail these waters, and they were immediately terrified. They named it Pontus Axenos, the inhospitable sea. The storms here were vicious and unpredictable. The coastlines were ruled by fierce, unwelcoming tribes who had little patience for foreign sailors. Navigation was treacherous. Ships were lost. The Greeks had good reason to fear these waters. But ironically, the Greeks eventually conquered their fear. They built colonies along the coast, established ports and trade routes, and in a classic display of ancient PR spin, renamed the sea Pontus Euxinus, the hospitable sea. A complete reversal. They were essentially trying to rebrand a notoriously dangerous place to encourage more settlers. It didn't really work in terms of the name sticking. Over the centuries, different waves of power swept through the region. Nomadic tribes, Byzantine emperors, Mongol armies. And then came the Ottoman Turks, who gave the sea the name that finally endured. Kara Deniz, the Black Sea. Two simple words that have outlasted every empire, every dynasty, every civilization that tried to rename it. But why black? The popular explanations you'll find in most history books are underwhelming. One theory says that fierce autumn and winter storms churn the water so violently that it appears dark and ominous. Another says that after storms, the waves push dark silt and mud onto the beaches, giving everything a blackened appearance. Both of these explanations are basically saying bad weather, some mud, dramatic lighting. It's the kind of answer that technically makes sense, but somehow feels completely inadequate. And it turns out the real explanation was hiding in plain sight, not above the water, but far beneath it. For centuries, sailors and port workers noticed something deeply unsettling. When they dropped iron anchors, copper fittings, or metal chains into the depths of the Black Sea and pulled them back up, the metal came back completely black. Not rusty, not corroded in the usual way. Black, covered in a thick matte coating that clung to the surface like paint. It didn't matter what the weather had been like. It didn't matter how clean the water looked from above. Whatever lived in those depths was physically staining every piece of metal that dared to enter its domain. When chemists finally analyzed what was happening, the answer was simultaneously elegant and terrifying. The deep waters of the Black Sea are saturated with hydrogen sulfide, a dissolved toxic gas that smells like rotten eggs and is lethal in high concentrations. When hydrogen sulfide reacts with iron or copper, it triggers rapid oxidation and produces iron sulfide, which is intensely, permanently black. The Black Sea got its name not because of how it looks from the surface, but because of what it does to anything that sinks into it. The sea was literally blackening ships from the inside out. The discovery of hydrogen sulfide in the Black Sea wasn't just a satisfying explanation for a naming mystery, it sent shockwaves through the scientific community. Because when oceanographers actually measured how much of this toxic gas exists in the Black Sea, they got a number that made their blood run cold. 87%. 87% of the Black Sea's total volume, by far the largest body of water on Earth with this characteristic, is completely dead, utterly poisoned. A vast, lightless, oxygen-free abyss filled with billions of tons of hydrogen sulfide stretching down to a maximum depth of 2,212 meters. The beaches, the resorts, the entire tourism industry, the fishing boats, the swimmers, the children building sandcastles, all of it exists on a thin, fragile 150-meter deep layer of living water that floats on top of an enormous toxic void. To understand how this happened, you have to understand how the Black Sea is built and why it's unlike any other body of water on the planet. Oceanographers classify the Black Sea as a meromictic system. It's a technical term, but the concept is simple and profound. It's a body of water whose layers never mix. In most seas and lakes, wind, waves, and temperature changes constantly churn the water, blending deep layers with surface layers, distributing oxygen throughout the water column. In a meromictic system, this mixing simply doesn't happen. The layers are locked in permanent separation, like oil and water in a bottle that never gets shaken. In the Black Sea, this separation exists because of a brutal chemical inequality between two completely different types of water. The upper layer, the one we swim in, fish in, sail on, is fed by some of Europe's greatest rivers, the Danube, the Dnieper, the Dniester, and dozens of smaller rivers pour vaster quantities of fresh water into the Black Sea. This water is relatively light, cool, and low in salt. It sits on the surface like a lid. The lower layer is almost the opposite. It flows in from the Mediterranean Sea through the narrow Bosphorus Strait, and it is dense, heavy, and extraordinarily salty. It sinks immediately and stays down. It has nowhere to go. The Bosphorus is too narrow and too shallow to allow any significant circulation. So the dense Mediterranean water just accumulates at the bottom, decade after decade, century after century, millennium after millennium. The result is a permanent chemical wall called the Chemocline, sitting at roughly 150 meters depth. Above it, life, light, oxygen, fish, dolphins, algae, crabs, all the familiar texture of a living sea. Below it, nothing. Or rather, nothing we would recognize as life. No fish, no mollusks, no worms, no bacteria capable of surviving in oxygen-rich environments. Just the slow, ancient chemistry of decay and the gas it produces. If you were to physically descend through this boundary, the transition would be almost surreal. One moment, you're surrounded by the familiar activity of an ocean ecosystem. The next, you pass through an invisible threshold and everything stops. No movement, no sound, no life. The water becomes profoundly still. The darkness below you is absolute. You are standing at the edge of a world that has been completely separate from our own for thousands of years. And in that darkness, frozen in time, perfectly preserved, waiting, there are things that should not still exist. In any normal sea, a sunken wooden ship has a limited lifespan on the ocean floor. The process of decay begins almost immediately. Shipworms, marine mollusks with a talent for boring through timber, colonize the wood within months. Aerobic bacteria break down organic matter. Currents disperse the lighter pieces. Salt water corrodes metal fittings. Within a century, even the mightiest warship is reduced to a few iron cannons resting in a scatter of ballast stones. This is what happens everywhere else. This is not what happens in the Black Sea. When deep-sea research vessels began sending remotely operated vehicles into the hydrogen sulfide zone of the Black Sea, the footage that came back was almost impossible to believe. From the absolute darkness, lit only by the powerful floodlights of the underwater robots, the cameras began revealing ships, not the scattered, half-dissolved remnants of ships. Intact ships, ships with their masts still standing, ships with rigging still attached to the spars, ships with carved wooden decorations still crisp on their hulls, ships with steering mechanisms still in place on their decks, ancient Roman trading vessels, Byzantine galleys, Ottoman warships from the medieval period. All of them sitting on the seafloor looking as though they had sunk last week rather than hundreds or thousands of years ago. The scientific explanation is clean and complete. In the hydrogen sulfide zone, there is no oxygen. Without oxygen, the shipworms cannot survive. The aerobic bacteria that dissolve organic matter cannot function. The standard biological machinery of decomposition is entirely absent. And because the temperature at those depths is near freezing and constant, because there are no currents, because there is no light, and because the chemical environment actively suppresses biological activity, the result is perfect, permanent preservation. The Black Sea is the world's largest natural museum of maritime history, and it's one that was completely sealed and inaccessible until we developed the technology to peer inside it. Archaeologists who had spent their careers carefully excavating fragments of pottery from ancient Mediterranean shipwrecks suddenly found themselves looking at complete vessels from the same era, with intact cargo, intact equipment, intact structure. It was, for maritime historians, the equivalent of discovering a perfectly preserved Pompeii at the bottom of the sea. But the archaeologists weren't the only ones whose understanding of history was about to be completely upended. In the year 2000, Robert Ballard, the oceanographer famous for discovering the wreck of the Titanic on the floor of the North Atlantic, led a research expedition into the Black Sea. His team was equipped with state-of-the-art sonar equipment and sophisticated remotely operated vehicles. They were looking for ancient shipwrecks, and they found them. But they found something else, too, something that none of them had anticipated. At a depth of roughly 100 meters, several kilometers from the modern coastline, the sonar readings began showing something unusual. The seafloor wasn't just flat sediment. There were structures, shapes that didn't belong to natural geology. Ballard's team sent down the ROVs, and the cameras revealed what the sonar had suggested: the unmistakable remains of human habitation. Ancient wooden beams, still intact, stone tools, carefully shaped by human hands, fragments of ceramic vessels, the everyday pottery of a long-vanished household, all of it sitting on what was clearly, unmistakably, once dry land. Someone had lived here. Someone had built a home here, cooked meals here, raised children here, and then at some point in the distant past, the sea had come for them, and their world had been swallowed whole. To understand what happened, you have to go back not hundreds, but thousands of years, to a time when the Black Sea didn't exist at all in its current form. Around 7,500 years ago, during the late Stone Age, what we now call the Black Sea was a completely different body of water. It was a vast freshwater lake, deep, ancient, and landlocked. Its water level sat roughly 100 meters below where it sits today. Around its shores, early Neolithic peoples had built thriving settlements. They farmed, they fished. They lived in organized communities with tools, pottery, and a degree of cultural sophistication that we are still learning to appreciate. The lake was their world, and it had been their world and their ancestors' world for countless generations. Then, the Ice Age ended. The massive continental ice sheets that had locked up enormous quantities of the world's water began melting as global temperatures rose. The oceans swelled. Sea levels across the entire planet crept upward, slowly at first, then with gathering momentum. The rising Mediterranean pressed against the narrow land bridge, the Bosphorus. And at some point, perhaps with no warning at all, the barrier broke. What happened next was beyond any scale of disaster the people living around that lake could have imagined. The Mediterranean Sea poured through the Bosphorus in a cataclysmic torrent. Geologists who have studied the ancient sediment layers describe a waterfall of such incomprehensible power that it would have dwarfed Niagara Falls by hundreds of times. The lake level rose by as much as 15 centimeters per day. Vast territories were submerged within weeks. Everything along the shoreline, the villages, the farms, the graveyards, the sacred places, vanished under the advancing water. The people who lived there had to run. And run they did, scattering outward in every direction, carrying with them their tools, their knowledge, their stories, and the memory of a catastrophe so enormous that it burned itself permanently into human consciousness. Many researchers today believe that this event, the flooding of the Black Sea, is the real historical basis for the flood myths that appear independently in cultures across the ancient world. The biblical story of Noah, the flood narrative in the Epic of Gilgamesh, one of humanity's oldest written texts, the flood traditions of ancient Mesopotamian cultures. All of them describe a great deluge that destroyed a known world and forced survivors to flee. All of them carry the emotional signature of a real event, the desperate urgency, the incomprehensible loss, the world that was gone forever. The geological evidence now suggests that a real event capable of generating exactly these kinds of stories occurred in exactly this region at exactly the right time. And the remnants of that drowned civilization, the homes, the tools, the pottery, are still sitting on the floor of the Black Sea, preserved in the hydrogen sulfide darkness waiting for us to find them. There's one more chapter in this story, one that isn't ancient history at all, one that's happening right now. On September 11th, 1927, a powerful earthquake struck the Crimean coast near Yalta. The tremors were severe enough to damage buildings and send people fleeing into the streets. But the most terrifying thing that night happened offshore. Witnesses on the coastline described watching enormous columns of fire rise from the surface of the sea. Pillars of flame, hundreds of meters high, are erupting directly from the water. The entire horizon seemed to burn, the air filled with a heavy, suffocating smell, the unmistakable stench of rotten eggs mixed with something acrid and chemical. People who saw it described scenes that sounded like the end of the world. Soviet scientists who investigated afterward pieced together what had happened. The earthquake had disturbed the deep sediment layers and fractured sections of the seafloor. The pressure change forced enormous quantities of dissolved hydrogen sulfide and methane gas upward through the cracks. The gases rose through the water column, breached the surface, and entered the atmosphere, where the electrical storm raging overhead provided the ignition. The sea itself had burned. This was not mythology. This was documented, verified, witnessed by hundreds of people on the coastline. The Black Sea's toxic depths had briefly, violently announced themselves to the living world above. And here's what makes that fact more than just a dramatic historical footnote. It's becoming increasingly relevant right now. Modern oceanographers monitoring the Black Sea have identified a deeply troubling trend. The Chemocline, the 150-meter boundary between the living surface layer and the hydrogen sulfide abyss beneath, is rising, not quickly, not all at once, but measurably, consistently, year by year. The cause is a combination of factors, all of them connected to human activity. Global warming is altering water temperatures and disrupting what little circulation exists in the upper layers. Industrial pollution poured into the Black Sea through its major tributaries is depleting oxygen levels in the surface water. Excess nutrients from agricultural runoff cause massive algae blooms that consume oxygen as they decompose. Each of these processes, working together, is slowly starving the upper layer of the oxygen it needs to remain alive. And as that layer weakens, the hydrogen sulfide boundary creeps upward toward it. Scientists are very clear about what this means. The 150-meter buffer that separates the toxic abyss from the surface world isn't a fixed geological feature. It's a dynamic chemical equilibrium, and it can be disturbed. A sufficiently powerful earthquake, like the one in 1927, could force hydrogen sulfide to the surface. An extreme storm could mix the layers in ways they haven't been mixed in millennia. And if the Chemocline continues to rise, due to pollution and warming, even smaller disturbances could have catastrophic consequences. The cities along the Black Sea coast, Odessa, Istanbul, Constanza, Sochi, Varna, are home to millions of people. The tourist beaches welcome tens of millions of visitors every summer, and directly beneath the water they swim in, beneath the boats they sail, beneath the piers where they stand and watch the sunset, there's a 2,000-meter deep reservoir of hydrogen sulfide gas that has been building pressure for 7,500 years. This isn't fear-mongering. This is what the monitoring data says. This is what the scientists at oceanographic institutes across 6 countries publish in their research papers. The Black Sea is not a static system. It is a living, breathing, chemically active environment. And it is changing. To put a concrete face on just how hostile this environment is, researchers have conducted direct experiments. Teams have attached ordinary objects to deep-sea research vehicles and lowered them into the hydrogen sulfide zone, to depths of 800 meters or more, and then brought them back up to examine what happened. The results were striking even to experienced scientists. A clean white rope, after just a few hours in the toxic zone, came back gray and slimy, coated in a thick biofilm of anaerobic bacteria, microorganisms that are the only creatures capable of metabolizing hydrogen, sulfide instead of oxygen. These ancient, extremophile bacteria represent virtually the only life that exists in the dead zone. They don't need light, they don't need oxygen. They thrive in an environment that would kill any multicellular animal within minutes. Polished metal plates, iron and copper, came back within hours covered in thick black corrosion. The chemistry moves fast down there. It isn't a gentle process of aging and weathering. It's rapid, aggressive chemical transformation. The ancient sailors who gave the Black Sea its name weren't wrong. They were simply observing the same process that modern researchers documented in their controlled experiments. The sea does turn things black, and it does so because of a chemical reality that has no parallel anywhere else in the world's oceans. What those experiments also confirmed is the paradox at the heart of the Black Sea. The same environment that destroys metal so aggressively also preserves wood so perfectly. The hydrogen sulfide that blackens iron saves timber. The absence of oxygen that makes the deep zone uninhabitable for any animal also makes it impossible for the organisms that would normally consume and destroy organic material. The chemistry that makes the deep Black Sea so dangerous to the living is what makes it so extraordinarily valuable as a repository of the dead. In this strange, poisoned darkness, the sea has become the world's greatest accidental archivist. It has kept intact, for us, for our scientists, for our historians, for our archaeologists, a record of human civilization and maritime history that exists nowhere else on Earth. Ships that sailed trade routes in the time of Julius Caesar, vessels that carried spices and silk in the Byzantine era, warships from the height of Ottoman power, all of them waiting, all of them preserved, all of them telling stories about how people lived and traveled and traded and died in the ancient world. When you stand on a beach at the Black Sea today, and it is a genuinely beautiful place, warm in summer, dramatic in autumn, ringed by mountains and forests and ancient cities, it's almost impossible to hold in your mind the reality of what lies beneath the gentle surface. The sparkling water, the children playing, the fishing boats, and then, 150 meters down, an invisible line. And below that line, an entirely different world. A world without oxygen, without light, without any creature larger than a bacterium. A world that has been accumulating its toxic chemistry since before the pyramids were built. A world that once, briefly, explosively, turned an entire sea into a column of fire. The Black Sea is not black because of storms or mud or dark waves. It is black because its soul is black, because in its depths there is a chemistry so alien, so aggressive, and so ancient that it physically transforms everything it touches. The name, given by sailors who watch their anchors return from the depths coated in permanent darkness, turns out to be the most literally accurate geographical name in history. But that name carries something beyond chemistry. It carries a story of a catastrophe that reshaped the world, drowned a civilization, possibly seeded the myths that billions of people still recite today. It carries the warning of a 1927 night when the sea lit up like a furnace and people thought the world was ending. And it carries a quieter, slower, more modern warning. The warning of scientists watching their instruments, watching the Chemocline rise, watching the balance shift, and wondering what happens when the thing that has been held down for 7,500 years finally decides to push back. The Black Sea is extraordinary. It is beautiful. And it is, at its very core, a reminder that nature's most dangerous secrets don't always announce themselves. Sometimes they hide beneath the prettiest water in the world, in the dark, patient, biding their time.